All right, good morning. All right, just to let you know, last period we had a lot of issues with the internet. I'm not sure what's going on. I didn't, on my end, I did a speed test and my internet seems to be fine. So I don't know if the district's doing something, it's always like 3 hours later, oh, sorry. It's like, well, it messed up my whole lesson. So wish they wouldn't mess with things when I'm trying to teach. So if there's any issues, I'll just try to keep coming back, on, but I did get through the lesson last period. So if we completely shut down, there will be a YouTube video because I am teaching a new lesson today on 10.1. So the answers for 10.1, I did put the answers in Google Classroom. We are going to have an exam on 8193 on Tuesday morning at 8. So you want to put that on your calendar. I'll be sending out a announcement in Google Classroom. So an exam 8193. There is no practice exam for this. So you're just going to have to work the online problems and all the problems that I gave you in the lesson. Okay, before we get started, does anybody want to ask me any questions about 9.3? Okay, well, today in 10.1, we're going to be talking about inverses. And I've already taught inverses in 1.4. So in 1.4, we looked at inverses of linear functions. So now we're going to look at inverses of quadratic and cubic functions. So it's like I'm teaching two lessons in one. So remember the inverse? I'm going to review it a little bit. Remember that to find an inverse, you change f of x to y, you switch x and y, you solve for y, and you write it as the inverse notation. What? Remember that the inverse reflects over the identity. So I'll be reviewing a little bit, but I'm not going to be reviewing everything that I taught. I think in 1.4 was the inverse stuff for linear. All right. So I'm going to try to pin myself so I can see what you're seeing. Just so weird. Nothing's working today. I can't. So, okay, can you guys see me? Yep, okay. All right, so in this lesson, we're looking inverses. Of simple quadratic and cubic functions. And we're doing a lot of things that we've already done, but it's a lot of work. We're going to find the inverse. We're going to verify. Remember, we verified inverses by composition. Remember f of g of x and g of f of x? And then you're going to be required to graph both the function and the inverse, and we're going to use transformations for that. Let me see if I can pin myself again. This is driving me crazy that I can't see what's going on. Nope, I'm not there. I'm just not there. So frustrating. Nope. Whatever. Oh, hold on. I just showed up. There. Okay. Okay, so this is California Common Core Standard F-BF.4a. I'm going to review a little bit here, and I'm going to be doing the Explore with you. So if we had a set of ordered pairs, let's graph those and see what these look like. So left 2, up 4. Left 1, up 2, 0, 0. Right 1, up 2. Right 2, up 4. Now, I know that looks like a parabola, but we do not connect the dots. This is not an equation. These are singular points. And if you remember, to find the inverse, we could just switch these. So instead of -2, 4, it'd be 4, -2, 2, -1, 0, 0, right 2, up 1, and right 4, up 2. So right 4, down 2, right 2, down 1, 0, 0, right 2, up 1, right 4, up 2. Do you guys remember the identity? So the identity is a line y equals x that divides the coordinate plane in half. And the reason why it's called the identity is because when x is 1, y is 1. When x is 7, y is 7. When x is -3, y is -3. So remember this? See how the black points reflected over the identity to give the red points? Remember? Inverses, they reflect over the identity. Okay, so this is all I want you to know right now. Okay, I want to write something, but I don't want you to write it. I just want you to watch this. If I did this, and you reflect the parabola over the identity, do you see how the identity is not going to be a function? It's going to fail the vertical line test. So I'm just telling you, the parabola does not have an inverse function. So what we're going to have to do when I work with the quadratic, we're going to have to restrict the domain so that I can get an inverse function, because see how this inverse fails the vertical line test? All right, but you don't want to connect the points on your paper because those are distinct points. I just want to show you something, so I'll show you right now. So I'm going to write this down later, but because of this situation, the quadratic is called a many-to-one function. When we work with the cubic, we're not going to have to restrict the domain, and it's called a one-to-one function. I'm going to write all that on the board, so don't worry about that. So let me just give you some notes. Okay, so first of all, f of x equals x squared is a many-to-one function. The inverse, remember the notation, f inverse of x? The inverse must be restricted to be an inverse function. Because like I just showed you, if it's not restricted, it's going to fail the vertical line test. And then finally, if we restrict the domain to just to the right of 0, then the inverse function is going to be the square root of x, or we could restrict the domain to the left of 0, then the inverse function would be negative square root of x. So in my problems, I'm going to restrict it to the right. Okay, now let me show you everything we have to do here. So they're going to want us to restrict the domain. They're going to want us to find the inverse. They're going to want us to verify by composition that they are inverses. And then they're going to want us to graph the function and its inverse. So we do have a quadratic. I do recommend that you change this decimal to a fraction. That'd be 5/10, which is 1/2. So this is the quadratic, the parents being shifted by a vertical compression by 1/2. So we're going to restrict the domain. So the domain, we're going to say, is only to the right of 0. We're going to find the inverse. So we're going to change f of x to y. We're going to switch x and y. Now, I don't know if you recall this, but the book is doing this different, and it did it different in 1.4 too. They switch x and y at the end. We're not going to do that. Okay, it's just too confusing. I don't know of anyone who does it that way. And so we're going to switch x and y at the beginning. So switch x and y, solve for y. So we're going to multiply both sides by 2. So we get 2x is equal to, those 2's cancel, y squared. Take the square root of both sides using square root method. So remember, when you take the square root, don't forget plus or minus. So we get y is equal to plus or minus the square root of 2x. So we write the inverse. And since we restricted the domain of the parabola, we have to throw out the negative of the radical. So I'll say that again. Since we restricted the domain of the parabola, this guy is restricted to, think about it. If square root went off like that, negative square root goes off like that, and that's going to fail the vertical line test, so we won't have an inverse function. So we're calling it a function, wouldn't be a function. Okay, so now we're going to verify by composition. And if you recall, I taught f of g of x, meaning f of f inverse of x, so you could see it either way. And the other one would be g of f of x, or seeing it another way would be f inverse of f of x. So I'm going to do what I did before. So I'm going to carry down the f function, and I'm going to put in the inverse. that becomes the x of the f function. And the f function is 1/2 times something squared, and the something is square root of 2x. Okay, do you guys realize that a square undoes a square root? A square undoes a square root. They undo each other. So this would be 1/2 times 2x. So the 2's cancel, so we get the x we were looking for. Okay, now over here, we carry down g. The f function is 1/2 x squared. That becomes the x of the g function. So the g function is square root of 2 times something, and the something is 1/2 x squared. The 2's cancel, and you end up with the square root of x squared, which undoes each other, the square and the square root, so we get x. Now, on the last exam, a lot of you showed a lot of garbage and then showed x. I'm not going to put up with that this time. So you must know how to do this correctly. So you can't write a bunch of garbage and write x. You have to show the correct work. Okay, anybody want to ask me about the composition? Go ahead, I'm listening. Question? All right. Well, when we do the graph, we're going to do a transformation of the quadratic. So we have left one, up one, 0, 0, right one, up one. But we're not using left one, up one because we restricted the domain. So left one, up one does not exist in this problem because we're saying the parabola only exists to the right of 0. So we're going to do a vertical compression by 1/2. So vertical means multiply the y by 1/2, multiply the y by 1/2. So what we have here is we have 0, 0, and right 1 up 1/2, and we're only drawing half of the parabola. Now, if I were you, I would draw the identity because the identity is going to help out. Now, pay attention. This is a horizontal compression by 1/2. But like I showed you in the Explorer, can't we just switch the ordered pairs? So can I just say, okay, well, 0, 0, right 1/2, up 1. You can just switch the ordered pairs if you want. So 0, 0, right 1/2, up 1. And now we're drawing square root. So that would be the inverse function. So notice how they reflect, how the black graph F reflects over the identity. So the black is half the parabola that's been restricted, and the red one is square root function with the negative omitted because of the restriction of the parabola. Okay, I'm going to work another problem. Any questions about this one? Okay, let's do another one. Is it okay if I erase this or no?
Yeah, you're good.
Do the same thing. This is the quadratic shifted down 7. We're going to restrict the domain. We're going to find the inverse by change f of x to y, switch x and y. Solve for y, add 7, add 7. Take the square root of both sides. Don't forget plus or minus. Change y to the notation f inverse of x. And throw out the negative because we restricted the domain of the parabola. So this is the parabola shifted, the parent shifted down 7. This is square root shifted left 7.
Ms. Birch, can you move up your camera a little bit, please?
Up.
Yeah, that's good.
Okay. So we're going to verify that I did the right thing by composition. So you're going to put in the g function, which is the inverse. That becomes the x of the f function, which is something squared minus 7. So your something is square root of x plus 7. The square undoes the square root. So there's your x. Then we're going to do g of f of x. So bring down the g function and put in f. That becomes the x of the g function, which is your inverse. So something plus 7. So the something is your x squared minus 7. So those 7's cancel, and you get the square root of x squared, which the square undoes the square root. So there's your composition. So now when we graph, the quadratic, the parent points are left 1, up 1, 0, 0, right 1, up 1. But remember, we restricted the domain, so that one doesn't count. So we're going to shift it down 7. And down 7 would be negative 6. So what we have here is 0 down 7. And we have, I'm sorry, this is 1. Right 1 down 6. And don't forget what we're drawing here. I'm going to draw the identity. You're drawing half of a parabola. So this parabola is going like that. So that's your f of x. And then you can either, remember square root, the points are 0, 0, 1, 1. You could go left 7, or you could just switch these points to left 7, 0, left 6, up 1. So left 7, 0 be 1, 2, 3, 4, 5, 6, 7. And left 6, up 1. And remember what you're drawing here. You're drawing square root, which goes off to the right. So does that look like it reflected over the identity? So we're going to do some word problems now too. The word problems are actually pretty simple. In the word problems, you don't have to do a composition. You don't have to graph. So any questions about this problem? Can I erase it?
Yes.
Okay, so this is on page 482. A. Okay, this problem has to do with its distance. So read with me. The function d gives the distance, d in feet, that an object falls in t seconds. Write the inverse function, t of d. So they're giving us d of t, and they want us to write t of d to find the time t in seconds it takes for an object to fall, the distance in d feet. And then it says, and then after that, estimate how long it's going to take a penny dropped into a well to fall 48 feet. So it's a lot of writing, but it's the main thing you want to focus on find the inverse function. So they give us d of t is equaling 16t squared. So this really means distance in terms of time, right? So we could write it like this. Well, listen to this one. You don't, in word problems with inverses, you don't switch them. So we're not going to switch the variable. We're just going to solve for t in terms of d. So we're going to divide both sides by 16. We're going to take the square root of both sides. Don't forget plus or minus. And by the way, we should have restricted the domain because it's quadratic. Zero to infinity. So what you get here is a fraction under a radical, which you can have. So t of d then, we throw the negative out because it doesn't make sense anyway, right? Distance, time, negative doesn't make sense. This would be the square root of d over 4. So they gave us the distance in terms of time, and we wrote a function, which is an inverse function, which is time in terms of distance. So don't switch the variables, just solve for t. Okay, now, They want to know how long does it take for a penny to fall 48 feet? So wherever you see a D, you put 48 and you just work the problem. So we're going to do a prime factorization on 48. So 2 times 24, 2 times 12, 2 times 6, 2 times 3. So this would be 4 2s and a 3, all divided by 4. So 2 2s come out. And can you cancel the 4s? Can you cancel part of a product? Can you cancel parts of a product?
Yes.
Yes. So that's our answer, which makes no sense in a real life problem. So we're going to have to put it in the calculator. So can you guys put it in the calculator for me, please?
$1.73.
So it's going to take about 1.7 seconds for a penny to fall 48 feet into the well. So that's about it. Can I erase this over here?
Yeah.
So just like the other problems, when we're working with inverses for quadratics, with the quadratic being many to one, you have to restrict the domain. So let's do another problem. This is on page 483b. This problem has to do with science. So the function E gives the kinetic energy E in joules of an 8 kilogram object, that's the weight, that is traveling at a velocity, which is speed, of v meters per second. Write and graph the inverse function. I didn't graph it. Okay, it says write and graph the inverse function v to find the velocity v in meters per second for an 8 kilogram object to have a kinetic energy of E joules. After that, estimate the velocity required for the 8 kilogram object to have a kinetic energy of 60 joules. So don't get caught up with all the reading. Okay, they want us to write an inverse function, and they actually ask us to graph it, which I forgot to do. So, so we have E of E is equal to 4v squared. And since it's quadratic, we're going to restrict the domain from 0 to infinity. So this is really E is equal to 4v squared. Don't switch the variables with the word problem. Just solve for the other variable. So we're going to divide both sides by 4. You're going to take the square root of both sides. Don't forget plus or minus and split this up. Can't have a radical fraction under a radical. So here's your V in terms of E. We're going to throw out the negative because we restricted the domain. So what we have here is the square root of E divided by 2. So you guys, I forgot to graph, but this graph would be 1/2 times the square root of e. So that would actually be a vertical compression by 1/2 of the square root function. I'm not going to do it for the sake of time. So they said that they want to know what the velocity is for an 8-kilogram object to have a kinetic energy of 60 joules. So we want to compute V of 60. So wherever we see an E, we put a 60 into the formula. Now, let me just say this. The reason why these formulas are so valuable is I could put 60 joules in, I could put 120 joules, I could put 1,000,000 joules, I could put 5 joules, I could put 3.5 joules. So that's the beauty of a formula. It can be reused for different, in this problem, different joules. All right, so let's do a prime factorization of 60. So if I take out a 3 would be 20. If I take out a 5 would be 4, 2 times 2. So you have the square root of 2 times 2 times 3 times 5 divided by 2. So a 2 gets to come out, square root of 15 over 2. Can you cancel the 2's? Can you cancel parts of a product?
Yes.
Yeah. So we're going to have to put that on the calculator. So what's the square root of 15 on the calculator?
0.87.
Do it again, please.
3.87.
About 3.9, right? So an 8-kilogram object with kinetic energy of 60 joules is traveling at a velocity, which is speed, of about 3.9 meters per second. So an 8-kilogram, that's the weight, object with kinetic energy of 60 joules is traveling at a velocity of about 3.9 meters per second. All right, here's the bad news. I have to teach everything again with a cubic. So now, instead of x squared, we have an x cubed. Are you guys there? Are you guys okay?
Yeah.
So I just want to make a note. I said that the quadratic was a many to one function. And that's because we had to restrict the domain. The cubic is a one-to-one function. That means we don't have to restrict the domain. Watch, don't write this down, just look up here. The cubic looks like this, right? It's a snake that goes up on the right and down on the left. Well, the inverse goes right and left, and notice that it passes the vertical line test. So the inverse, it doesn't need to be restricted, because when you take the inverse, it is a function. So that's why it's called one-to-one. We don't have to restrict the domain. So we're just going to find the inverse. So this would be y is equal to 1/2 x cubed, switch x and y. So we're going to multiply both sides by 2. So those 2's cancel, we get y cubed. So we're going to take the cube root, not the square root. We're going to take the cube root, and we're not going to put plus or minus, because you don't do that with the cube root. So when you take the nth root of an odd index, you do not put plus or minus. So what you have here is you have y is equal to the cube root of 2x. So your inverse is the cube root. So this is the cubic vertically compressed by 1/2. This is the cube root horizontally compressed by 1/2. You guys okay? So we're going to do the compositions, f of g of x. So we're going to put in the g function, which is the cube root of 2x. That becomes the x of the f function. So we put that into the f function, and notice that the cube undoes the cube root. So what you have here is 1/2 times 2x. So the 2's cancel, and you get your x. So to do the other one, we do g of f of x. So we bring the g down and put the f function in. And the f function is 1/2 x cubed. That becomes the x of the inverse, which is the cube root of 2 times x. And your x is 1/2 x cubed. So the 2's cancel, and you get the cube root of x cubed, which undo each other. So when we graph this, I would draw the identity. And remember, the cubic has 3 points, left 1, down 1, 0, 0, right 1, up 1 for the parent. And this is a vertical compression by 1/2. So vertical means y. So multiply by 1/2, multiply by 1/2, multiply by 1/2. So when you graph those points, you get left 1, up 1/2. Sorry. Left 1 down a half, 0, 0, right 1 up a half. And so your cubic, remember, don't forget that your cubic goes up and down. So this guy's going up and this guy's going down. And then the cube root, remember he has the same exact points. And we could do a horizontal compression by 1/2, but instead I'm just going to switch these because we know I can do that. So -1/2, -1, 0, 0, 1/2, up 1. So this would be left a half, down 1, 0, 0, right a half, up 1. And don't get confused about this. The cube root goes to the right and the left. So the cubic goes up and down. Can you guys see this? The cubic goes up and down, and the cube root goes left and right. So this one's going to go to the right, and this guy's going to go to the left. And there's your inverse. All right, any questions about the composition? I'm going to erase that. Okay, can I erase this over here?
Yeah. Okay, so this is the cubic shifted down 9. You don't have to restrict the domain because it's a 1-to-1 function. We're going to find the inverse. So y is equal to x cubed minus 9. Switch x and y. And I told you that the book doesn't teach it this way, right? The book switches it down at the bottom. We're not doing that. We're switching it right away. All right, so switch x and y. Solve for y, so add 9. Take the cube root. So the cube and the cube root undo each other. So this would be the cube root. Don't put plus or minus. When the index is odd, you don't put plus or minus. So the inverse then is the cube root of x plus 9, which is the cube root shifted left 9. Let's do the composition. F of g of x. So you bring down the f function, you put in the inverse. That goes into the f function. So the f function is x cubed minus 9, which is something minus 9. And the something is the cube root of x plus 9. So like I said, the cube and the cube root undo each other. So there's your first x. Then we're going to do g of f of x. So bring down the g function and put in the f function, x cubed minus 9. That becomes the x of the g function, which is the cube root of something plus 9. And the something is x cubed minus 9. So those 9s cancel. And you end up with the cube root of x cubed, where the cube and the cube root cancel each other out or undo each other. So there's your. So when we graph these, the cubic is the parent points are left 1, down 1, 0, 0, right 1, up 1. And this is down 9. So down 9 would be negative 10, down 9 would be negative 9, and down 9 would be negative 8. So we have left 1, down 10. We have 0, down 9, and right 1, down 8. Do not draw a line. This is a cubic. So this guy is going up on the right and down on the left. The inverse, you can just switch the point or take the cube root left 9. So we go left 10, down 1. We go left 9, 0, and left 8, up 1. And remember that the cubic goes up on the right, down on the left, and the cube root goes right and left. So you're drawing this guy to the right and to the left. That's a weird graph, but it does reflect over the identity. All right, I'm going to do 2 word problems with the cubic and we'll be done. Do you guys have any questions about this? Okay, can I erase this board on the right?
Yes.
All right, how about this one?
Yeah.
All right, look on page 487A. This is actually a fish problem. It says the function m gives the mass, which is the weight, in kilograms of a red snapper of length L centimeters. Find the inverse function to find the length L in centimeters of the red snapper that has a mass of m kilograms. So they're not having us estimate or do anything. They just want the function. So they're telling us that the function is the mass in terms of length, and it's equal to 0.12341, which is 1 over 100,000 L cubed. Now, I would change this decimal to 1 over 100,000. This is m. So the first thing we're going to do is we're going to multiply both sides by 100,000. So those cancel. So we get 100,000 m is equal to L cubed, and now we take the cube root of both sides. Don't put plus or minus. And we would write it, they gave us the mass in terms of length, and now we wrote the length in terms of mass. And that's good enough. All right, let's look at a geometry problem on page 487b. So they're saying the function a gives the surface area of a sphere with radius r. Find the inverse function r of a to find the radius of a sphere with a surface area. So once again, they just want us to write the inverse function. We're not estimating or doing anything. So this is a is equal to 4/3 pi r cubed. So with these problems that we're modeling and finding an inverse, we don't switch the variable, just solve for r. So I'm going to divide both sides by pi first. And if you divide by pi, it goes away. So the next thing I'm going to do is I'm just going to multiply by the reciprocal to eliminate the fraction. So the 3's cancel, the 4's cancel. And we get r cubed is equal to 3a over 4 pi. And then I'm taking the cube root of both sides. So that would be the radius in terms of the area. And lots of times with formulas, you guys, I do realize, look at this, this is a big mess. You have a fraction under a radical, but you also have a decimal under a radical under a fraction. And so this is, since this is so complicated to simplify, we're just going to leave it like that. Because pi is a decimal, right? So we have a decimal in the denominator and we have a fraction under a radical. So for us to simplify it, not only would it be a lot of work, but it's going to look more complicated in this. So since this is a formula, just leave it. All right, you guys, I made it through the lesson. So that is the lesson. And it is 11:15. Class is over at 12:10. So we're not going to report back, but let me tell you what I want to do. I want you guys to go into your Math Wizard teams, and I want you to decide on a problem in the book. So it could be problem number 1, it could be problem number 5, it could be a word problem. I don't care. But until 12:10,
I want you to work as many problems as you can with your group. So just decide what problems you're going to work and try to work through the kinks. All right? All right, I'll be taking attendance in the Math Wizard team, so we're not going to report back. I hope you guys have a fabulous weekend, and I will see you in your teams. Okay? All right, I'll see you in your teams.